The scary job of cleaning multi-billion-dollar ships. During the journey of a ship, a lot ensues on the submerged parts of the ship, as marine animals like barnacles and worms built up on the submerged parts of the ship. They can create many problems. Divers, for that reason, are sent underwater to clean the gigantic superstructures and eradicate these parasites. They enter the world in which they put their own lives in danger as well. These divers are specially trained to work long hours in dark waters. Their jobs need them to work only in menacing conditions. In an environment where there are frequently toxic chemicals, asbestos, and oil, workers employ gas blowtorches and sledgehammers to take apart the ship in a process that takes 6 to 8 months and up to a year for big tankers. Moving cranes, falling steel plates, gas explosions, and metal coils snapping are all constant dangers at the yard. 12 hours a day is typical, and wages are as low as US $2 a day. Although official figures are unknown, unions in the region presume that hundreds are killed or seriously wounded every year at work in Bangladesh, Pakistan, and India. In Bangladesh, the real figure could be 20 times higher than what is revealed, according to the unions and NGOs. Under the hulls of giant ships, there is often no direct way back to the surface, and the diver may meet with great danger under the hulls. Biological fouling rusts the paint and metal and causes a series of issues by elevating the weight and resistance of the vessel. It also curtails fuel efficiency, racking up costs and damaging the environment. Some biofilm also builds on the base of the aircraft carrier while it is out at sea. Fouling organisms affix themselves to all subsurface structures such as propellers, rudders, inlet and outlet ports, and protective grills. As a result of this attachment, biofilms grow. Therefore, it's essential to remove them. Most vessels on average renew their coatings every 3 to 5 years. Additionally, in the US Navy, it is suggested that cleaning work be carried out on the propellers 6 times each year, while cleaning work on the hull is to be carried out 3 times per year. While purging the hull, divers are often exposed to the toxins some of the biofilms contain. A few are even harmed in the process. Periodic underwater cleaning, dry docking cleaning, and anti-fouling paint are the strategies most frequently employed to emulate bifouling on hulls of vessels. When cleaning the hull of aircraft carriers, it might be needed to dive to depths that are greater than those typically associated with diving. Due to the depth with circumstances like this appearing, saturation diving is performed by using professional saturation diving equipment. Divers can live and work at pressures of more than 50 MSW for periods of several days or even weeks at a time. You enter a unique world as a saturation diver. You work with 2 or 3 people and slumber in a decompression tank. They live there for some time up to 28 days and breathe a mixture of helium and oxygen. Cleaning ships can take up to 6 hours before they return to their SAT chamber to alter shifts. There are medical and psychological consequences to living under saturation for extended periods. Bell balance ambient pressure diving is the more ordinary type of diving. There is some sign that saturation divers have a slow decline in their lungs function throughout a long period during and after saturation exposure. Divers are often exposed to superficial infections such as skin rashes, otitis externa, and athlete's foot. These infections can be a source of considerable discomfort for saturation divers. It's believed that this arises from increased partial pressure of oxygen and relatively high temperatures and humidity levels. Within the accommodation saturation, dives are becoming less common due to the accelerated use of underwater remotely operated vehicles and autonomous water vehicles. For hull cleaning, the utilization of physical labor has gradually given way to utilization of mechanical and electronic equipment for underwater cleaning, especially for larger vessels like aircraft carriers. The cleaning industry has introduced handheld cleaners, huge cleaning equipment, and cleaning robot systems. When cleaning portions of the hull that are flat or have a minor curve to them, large brush devices are normally the best choice. Nonetheless, when cleaning a propeller, small brushes tend to produce improved results. Large rotary brush devices could have a single brush, double brushes, or many brushes, all of which are controlled by hydraulic motors. The motorized rotating devices rotate the brush units, creating an absorption force. This force stimulates the device to be drawn to the vessel's hull. The divers can alter the cleaning direction of the device as well as the pace at which the brush rotates in response to the regions that need to be cleaned. It's advised that when utilizing the procedure of periodic underwater cleaning, one uses hard coatings that have a lifespan of at least 10 years and can even elongate the hull's lifespan. Hard coatings that can be cleaned underwater are the best solution in the long run to cleaning the hull of aircraft carriers underwater. Many disadvantages are involved when divers clean the ship while it is submerged in the water. Some of these drawbacks include a high labor intensity, low efficiency, limited working time, and the possibility of personal damage to avoid human error and prevent deaths. The use of robots is progressively common. The fast manufacturing of digital electronics and transducer technology over the past 2 decades has made it feasible to use ultrasonic cleaning technology to clean ships while they are submerged in the water. They can be remotely managed and attain depths that cannot be attained by humans. ROV operators must be experienced to work with these equipments, as this job is very high-tech and necessitates a lot of knowledge. These technologies must continue to be developed for the safety of divers ship owners.